We are going to learn the product rule and quotient rule today for derivatives. In our previous sections, we learned that the derivative of a sum or a difference is simply the sum or difference of their derivatives. Stated like this: the derivative of a sum is the sum of the derivatives. And we used that all the time without thinking about it. If we were given this equation for y, this is the sum and difference of a variety of functions, right? So to find the derivative, we just went piece by piece and found the derivative. So the derivative here would be, using the power rule, 21x to the 6th plus 36x squared minus 17 plus 0. And so that would be the derivative. The derivative of a sum or a difference is just the sum or difference of the derivatives. What if, instead of a sum of terms, we have a product of terms? The question is the derivative of a product the product of the derivatives? And the short answer to that question is no. Unfortunately, the derivative of a product or a quotient is not that simple. Here is the product rule, and there is a proof of this product rule. It's rather lengthy, so I'm not going to show it to you, but it is widely available if you'd like to do a little search for it online. So here's the product rule. The derivative of a product is, you begin by taking the derivative of the first term and multiply by the second term left alone. Then you add the derivative of the second term multiplied by the first term left alone. Of course, since this is a plus, we could totally switch these two things. And since this is a product of each of the two terms here, we could switch each of these. So there's some switching going on. Normally, you'll see that I always begin by taking the derivative of the first term present. But sometimes I do switch these depending on what these functions are. All right, let's look at some examples. In example 1 here, we have f of x is equal to a product of two terms. So since I have two terms being multiplied together, I'm going to use the product rule. Okay, I could instead distribute and combine all of my like terms, but that's going to take some time. It's going to be a lot easier to find the derivative of f using the product rule. So that's what I'm going to do. So I'm going to take the derivative. I'm going to start with my first term and take its derivative. So that's going to be, I like to put this in parentheses. You'll see I do that a lot, especially at the beginning here. So the derivative of x to the 4th is 4x cubed. The derivative of the next piece is negative 6x, and the derivative of 9x is 9. Close parentheses. We just found the derivative of our first term. We're going to multiply by the second term left alone. Plus. Now we take the derivative of the second term. And that's going to be 10x to the 4th plus 4x cubed plus 0. The derivative of negative 12 is 0. Close parentheses, and I'm going to multiply by the first term left alone. So in each of our pieces, we have one term that's derivative and one term that is the other side left alone, the other piece left alone. And that's the derivative. It's a little lengthy, but that's okay. We could, if we wanted to, distribute and combine like terms, but there's no need to do that here. Number 2, let's find the instantaneous rate of change of y with respect to x in terms of x. This just means we're going to have x's in our answer. In terms of x means we'll have x's in our answer. Okay, I'm looking at y and I see a product of two terms. This is a product of x cubed and sine x. So I'm going to use the product rule. So to find the instantaneous rate of change, that is dy dx, or the derivative, I'm going to begin by taking the derivative of the first piece, the first term. The derivative of x cubed is 3x squared, and I multiply that by the second term left alone, plus. Okay, now I know I'm going to be taking the derivative of sine x and multiplied by the x cubed left alone. This is one of those cases when I have a trig function back here, I like to begin with leaving this x cubed left alone. And now I'm multiplying by the derivative of sine x. The derivative of sine x is cosine x. And that would be our answer. We can remove these parentheses. Oops, we can remove these parentheses and just write this as 3x squared sine of x plus x cubed cosine of x. That's how you would see it as a multiple choice answer. What is the slope of the line tangent to this curve? Well, slope of the line tangent is just another word for derivative, and we want to find it exactly when x is pi over 3. So I'm going to type find g prime and then plug in pi over 3 for x. I'm looking at g and I see a product of two terms. So I'm going to use the product rule. G prime of x is equal to, alright, the derivative of 6 sine x is 6 cosine x. I'm going to multiply by the tangent x left alone, plus. Now I'm going to leave the 6 sine x alone and multiply by the derivative of tangent x. The derivative of tangent x is secant squared x. So that is g prime of x, and now we're going to plug in pi over 3 for x. Okay, I'm going to have 6 times cosine of pi over 3 is 1/2. Tangent of pi over 3 is square root of 3. Plus 6 times sine of pi over 3 is square root of 3 over 2. Secant of pi over 3 squared, right? Well, secant is 1 over cosine. Cosine of pi over 3 is 1/2. We're flipping 1/2, which will be 2, and then we need to square it because of the squared there. Okay, this will be 2 goes into 6 3 times, so that's going to be 3 square root 3 from that piece, plus 2 goes into 6 3 times. 3 times 4 is 12. Square root 3. Combine our like terms, 15 square root 3. This would be the multiple choice answer. Okay. Next we're finding h prime of 2 if h is this function and this is another product. I have two pieces being multiplied together, so I'm going to use the product rule. First I'll find h prime of x, and then I'll plug in 2 for x. I start with my first term, take the derivative. The derivative of 3x is 3. The derivative of negative 2 is just a 0, so the derivative of our first piece is just 3. I'm going to multiply by the second piece left alone, plus. Okay, the derivative of this term is 4x minus 8. The derivative of 1 is 0, multiplied by 3x minus 2 left alone. Okay, time to plug in our 2 for x, and I will have 2 times 4 is 8, minus 16 plus 1, plus 2 times 4 is 8, minus this 8, that's just going to be a 0. Doesn't really matter what's back there then, because that piece is just going to be a 0. This is 3 times negative 8 plus 1 is negative 7, so this turns out to be a negative 21. Multiple choice answer. Alrighty, so that's the product rule. Now we're going to talk about the quotient rule. What if you have a quotient of terms rather than a product of terms? Well, if you have a quotient, you need the quotient rule. And the quotient rule is a bit more complicated than the product rule was. Okay, some things to keep in mind. In the denominator, there's no derivative. No derivative in the denominator. Okay, it's a common mistake I see kids. They want to put a derivative in the denominator. So, nothing like that. Also, another note. In the numerator is identical to the product rule. Let me get the product rule up here. Except for one thing. Look at the numerator. The numerator is identical to the product rule except for the plus sign. It should be a minus sign. Everything else is identical. Okay? So, I like to think of the quotient rule is a quotient, no derivative in the denominator, and instead of a plus, a minus in between the two pieces in the numerator. So let's take a look at some examples. Example 1. First of all, this is a quotient because we're dividing two terms. So we are going to use the quotient rule. Okay, here's my thought on it. I'm finding f prime. Okay, I start on top. Start on top, take the derivative. The derivative of that is 5. Multiply by the bottom left alone. No derivative. Minus. Now I take the derivative of the bottom. The derivative of the bottom is 2x. I multiply that by the top left alone. All divided by the bottom left alone, no derivative, but squared. That's how I do it. That's my thought process on it. And that's it. For a multiple choice answer, they would probably distribute and collect like terms up on top. So distribute, distribute. Combine our like terms. Oops. And that would be the multiple choice answer. Number 2, find the instantaneous rate of change. That's another word for derivative. IROC, instantaneous rate of change, of y is equal to this function in terms of x. So we'll have x's in our answer. Well, I see two things being divided, so we are going to use the quotient rule. dy dx, the instantaneous rate of change, the derivative, is equal to, okay, I start on top and take the derivative. Start on top, take the derivative, 2x. Multiply by the bottom left alone. minus. Now I take the derivative of the bottom multiplied by the top left alone. So the derivative of the bottom is negative sine x multiplied by the top left alone will be the x squared. All divided by cosine of x squared. The bottom left alone, but squared. As a multiple choice answer, they would just remove the parentheses on top, move the x squared to the front, and put the square where it is traditionally seen in a square of a trig function. And that's it. Note, do not cancel out a cosine x. There's no cosine x in this piece, so you cannot cancel there. Okay, number 3. What is the slope of a tangent line? It's another word for derivative. To this curve G at the point when x is pi over 3. Well, I see a quotient, two terms being divided, so I use the quotient rule. At the end, we'll plug in x is pi over 3. Okay, so g of x is equal to, start up on top, take the derivative. The derivative of secant x is secant x tangent x. So secant x tangent x times the bottom left alone minus, now the derivative of the bottom, that's just a 1, times the top left alone, all divided by the bottom squared. The bottom left alone, but squared. So that's g of x. Now we're going to put in pi over 3 for x. Okay. Secant of pi over 3 is 2. Tangent of pi over 3 is square root of 3. X is pi over 3 minus secant of pi over 3 is 2. All divided by x squared. Pi over 3 squared is pi squared over 3 squared. That's pi squared over 9. This is a complex fraction. It would be fine for a multiple choice or for an FRQ question, but for a multiple choice question, they would get rid of the complex part of this fraction. So they would multiply top and bottom by a 9. Because a 9 will get rid of this 9 and it will get rid of that 3. So we're going to have this 3 will reduce with a 3 from the 9, but it will still leave a 3. So that will be that 3 times the 2 times square root of 3 times pi minus 2 times 9 is 18 divided by, these 9's cancel out, leaving the pi squared. So this is 6. Usually we see a pi before a root. So 6 pi square root 3 minus 18, all divided by pi squared. This would be the multiple choice answer. Okay. Next example, find h prime of 2 if h is this function. This is a quotient because it's two things being divided. So I'm going to use the quotient rule. I actually have a choice on this one, but so far this is our only option. So I'm going to use the quotient rule. I'm first going to find h prime of x, and then I'll plug in 2 for x. I start up on top and take the derivative. The derivative of 7 is 0. I multiply that by the bottom left alone. Don't really have to show that because that piece is just going to be 0. Minus, Now I have the derivative of the bottom. The derivative of the bottom is 3x squared. I multiply that by the top left alone, all divided by the bottom left alone, but all squared. Like that. Okay? Now I will plug in 2 for x. This piece is gone, it's just a 0. So I have a negative 3 times 4 is 12 times 7 divided by 2 cubed is 8 plus 8 is 16 squared. Okay? Now, I know I have a 4 in 12, and I know there's a 4 in 16, so watch what I do for this. I'm going to write that 12 as 3 times 4, and I'm going to write 16 as 4 times 4, but it's being squared, so that's going to be 4 times 4, that's 16, and then another 4 times 4 for the other 16 down there. 4 goes into 4 once, so this is going to be a negative 21 over 4 times 4 times 4, 64. So that's how I would simplify that myself if I didn't have a calculator in my hand, which I don't. Alright, so that was the quotient rule. It's very important. These are both really important rules. A word about higher order derivatives notation. The first derivative we can write as dy dx or f prime. If you take the derivative of the first derivative with respect to x, you get the second derivative, which is the second derivative of y with respect to x, also known as f double prime. If you take the derivative of the second derivative, you get the third derivative. These are both notations for the third derivative. And I would pronounce this f triple prime. This is the third derivative. This is f triple prime. We can also have the fourth derivative. This would be the notation. You don't keep adding hash marks here. You don't keep adding primes. This is pronounced the fourth derivative of f. This is the fifth derivative of f, and then it would keep on going. So this would be the notation for the nth derivative of f with respect to x. Just a word about notation. You can keep on taking more and more derivatives. And that is the quotient rule and the product rule and a word about notation for higher order derivatives.